Hello, everyone. It is the Prophet Michael David, aka Aries, and happy Friday to everyone. Hope everyone's having a great day. So, I realized recently on some of the math videos I did that were somewhat popular compared to my other videos, is that I know exponentially more about primes than you all do. And so, I'm going to take this video to basically teach you at least the basics on primes, and it will give you a much greater understanding on why my work is structured the way it is. A lot of you have heard the phrase that a prime number is a number that is only divisible by itself and 1. And sometimes you'll see some pretty good analogies, like this next one from Wiki that shows you how prime numbers differ from composite numbers. But the way I'm going to teach about primes is I want you to envision primes or numbers as lines or cakes, or you can think of pizzas if you want to think of them that way. Now let's go back to that pretty standard first definition of a prime that I gave you, that a prime is a number that's only divisible by 1 and itself. Well, first, let's talk about what it means to be divisible by 1. It's only a mathematical thing, because in the physical universe, if you divide anything by 1, it remains undivided. It's still a single unit. And the other part of the phrase, to divide something by itself, well, that's synonymous with dividing it into only single units. That's what it means. You're dividing it into ones. So, the very best way to think of a prime number, metaphorically speaking, is as a line or a pie or a pizza or something that you can only divide into single units because it's not divisible by anything else. You can only divide it into ones. And now we're going to go over some examples up to like 12 to prove this point. Okay, so I guess I'm always thinking about the cake or the pizza. That's how I'm going to describe it, but here we go. One, we don't need to. We're not dividing anything. Two, just divide it down the middle. That's easy. Three, Mercedes symbol, and that's easy. Four, also easy. Divide down the middle, divide again. Five is also easy. Just do a star and then divide it that way. Six, also easy. Divide it down the middle. Take one side, divide into threes. Seven, that's where it gets difficult. Most humans cannot divide something up into 7 equal segments. Some can because they do it for jobs or whatever, and they're trained to proportion and everything. But that's why 7 is prime. You can only divide it up into single units. It's difficult. 8, easy. That's pizza. 9, Mercedes emblem, and then take 1/3, divide that into thirds. That's 9. 10, divide in half, and then take 1/2, and then divide into 5, which is difficult, but we can do pretty well. But then we get to 11, and you're like, yeah, that's really difficult because, again, it's prime. You can only divide it up into single segments. You can't, it has no other divisors. And then 12 is easy. You can do it a whole lot of different ways because 12 has a whole lot of divisors. All right, next thing. All primes have to be odd numbers that end in 1, 3, 7, or 9. Why? Well, no prime numbers can be even except for 2 because all even numbers are divisible by 2. No prime numbers can end in 5 except for 5 because then they become divisible by 5. And because we do math in base 10, anything that ends in 0 will also be divisible in 5. So no evens, no 5. That leaves you with 1, 3, 7, and 9. And here's a little graph of them and the different composites and squares they can form. As you can see by that little times table chart that I made, uh, when primes end in 1, 3, 7, and 9, all composites, combinations of two primes, and all squares of primes also have to end in 1, 3, 7, or 9. But even more that, if you look closely, all squares of primes can only end in 1 and 9. 1 times 1 equals 1, 3 times 3 equals 9, 7 times 7 equals 49, ends in 9, and 9 times 9 equals 81, ends in 1. And that will happen for any primes that end in those numbers. Which means a really good definition for prime is an odd number which ends in 1, 3, 7, or 9, which is not divisible into anything except single units, and whose square always ends in 1 or 9. And this holds for almost all the primes, except a few at the beginning, and I'll explain those now. Okay, most mathematicians these days do not consider 1 a prime, mostly because it screws up their theory of arithmetic, but the other part is that it's just not divisible by anything. 2 is prime, but it's the only even prime, and 2 times 2 equals 4, and 4 does not end in 1 or 9, so it doesn't satisfy our conditions in that definition we just came up with. And then we have 3. 3 is also prime, and 3 times 3 equals 9. What disqualifies 3 on this one is another requirement that all primes have to have that we've talked about previously, is they all fall on the 5 mod 6 line or the 7 mod 6 line. And 3 is the only prime that falls on the 3 mod 6 line. Finally, we have 5. 5 is prime, but 5 times 5 is 25, and 25 does not end in 1 or 9, which disqualifies it on that, because 5 is the only prime that ends with 5. I know that sounds like a lot of weird disclaimers, but the start of the number line is like the start of the universe. Just it's crazy, crazy weird, and does not really relate to the rest of it in at least the things that it has to conform to. It's degrees of freedom or whatever mathematicians or scientists would like to call it. But at 7, everything holds from 7 on to infinity for primes. 7 is a prime, only divisible by ones. 7 times 7 is 49, which ends in 1 or 9, and 7 by definition is on the 7 mod 6 line. One more, but I assure you after 7 they all hold to infinity. All right, the next prime after 7 is 11. 11 is prime, only divisible into ones. 11 times 11 is 121, ends in a 1 or a 9. And 5 plus 6 is 11, so 11 is on the 5 mod 6 line. Right, I've shown you all that table before, but just as a refresher, the blue numbers are 5 mod 6 primes, the green numbers are 7 mod 6 primes, the orange numbers are composites, and the pink numbers are prime squares. And finally, just as an add-on for those of you that are looking at that graph wondering about the pink prime squares, do all of them fall on the 7 mod 6 line? Yes, they do. While all of the primes must fall on either the 7 mod 6 or 5 mod 6 line, all the prime squares and the primes to the 4th power and the primes to the 6th power, etc., have to all fall on the 7 mod 6 line, all of them, to infinity. So if you made it up to this part of the video, you probably know exorbitantly more about prime numbers than you did before, and especially about their nature, the ways they have to conform, the way they have to fit in the number line. And hopefully you've learned or it's shown you a little bit more about my personal method, and you might be thinking, oh, okay, now I understand more, while everybody else is just trying to find them using some sort of wave functions or whatever. He actually tried to split the line system up and just analyze them on the lines that they fell on, which is only 2 out of 6 lines. Yeah. And even more than that, he likes to deal with squares, not the regular primes, because they're almost as unique as the primes themselves. And they only fall on one of those 6 lines. Yep. And that's what I did. I'm a geometer and I don't have that much computing power. We look for patterns and tendencies and everything, and that go on to infinity. In other words, I'm not the guy that's trying to find all the prime numbers in the universe by brute forcing my way through the entire number line. I'm the guy that's trying to find all the primes in the universe by eliminating all the numbers that they can't be. Okay, I'm gonna sign off here, at least for this video for the day. But again, I think it's a really good video if you watched it up until the end that explains the nature of the primes in my personal analytic style. It'll be very good for the next video. I'm gonna delve back into the twin prime solution, or my twin prime solution, and try to prove it even more. And this will be a very good video to know, that'll help you out with that one. So as always, rule number 1, do not touch each other without another person's consent, aka do not hurt each other, and it's all about honesty. Lies are a tick down, aka try not to lie.